Yes, hello folks, we are coming to the part 3 video of this miscellaneous exercise, and we are there with the fourth problem now. There is going to be a shape change. All this time we have been learning all the 3 problems, they were of parabola. Now this time it's going to be ellipse and some other cases that is going to come up. That is what is going to come up in this upcoming part. So let us take now the question number 4. It says that an arch is in the form of a semi-ellipse. Right, we have got the ellipse. An arch is in the form of semi-ellipse. It is 8 meters wide and 2 meters high. Like all other questions, they give you the height and the diameter or whatever. That gives you, why they give you, so that you get a point on it. And once you get the point on it, they give you something else, that come on now find this, right? So they say, find the height at a point which is 1.5 meters from the end. So that's how it is. This has been throughout happening in every problem in the exercise. What they've been doing is they would tell specification of the shape. So with that we decide the equation. Then they give us the dimensions at certain speeds with which you are able to predict a point. And once you get the point, you are able to get the curve. And then they say, come on, now I am throwing up, come on this point, come on that point, come on that way, come on this way. And now you find the remaining things from there. So that is what is happening throughout the exercise. Yes, so that is exactly what's happening here, but except for the fact that it's a semi-ellipse. You have to get the semi-ellipse and then do what? First, let's read the question carefully to know what type of ellipse it is. We have learned only 2 ellipses. One is which is having x-axis as a major axis, or which can have y-axis as a major axis. So let's decide whether it's going to be x-axis major or y-axis major. An arch is in the form of a semi-ellipse. They don't tell that, but they say it's an arch. So we can understand that arch, if it has to be an ellipse, obviously you cannot have arches like that. You cannot have those vertical ones. So it should be, the axis should be vertical, and then it should be based on the horizontal. So you should have your major axis as the x-axis. So it is obviously going to be type 1. Okay. Now as I said, my sense of symmetry will go very bad. So that is why I may not be able to draw it semi-ellipse and all that. So we will draw the ellipse and then make it a semi-ellipse. So probably let's have it. It's looking okay. So I think I will not go in for full ellipse, semi-ellipse. Okay, so this is your arch. This is what they are trying to tell us, that though it's not very perfect, but it's too good for my level. Considering my kind of drawing, it should be like you could give it 9 out of 10. Yeah. Things have to be relative also, right? An artist doing a certain thing and struggler like me doing, does matter, right? So anyhow, so that's a semi-ellipse. There is an arch which is of the type of a semi-ellipse, and we know that if this was a full ellipse, its equation would have been x squared by a squared plus y squared by b squared equal to 1. So that is the equation. Then they tell us something about the points. That let's check out. What do they say? They say that an arch is in the form, it is 8 meters wide. So it's been given to us that the width is 8 meters. The ellipse has got width 8 meters, and it is 8 meters wide and 2 meters high at the center. At the center, the height is 2 meters. Very, very specific. They have given us specific details about the ellipse. They say that find the height of the arch at a point 1.5 meters from the end. Suppose if I take a point which is 1.5 meters from the edge, then I must be able to find what is the height. That is the question. Quite clear, actually. Quite clear, though it calls for a little bit of working, but it's very clear that things are systematically done as it is done always. They tell you the shape and they tell you sufficient data which allows you to predict the equation. Then they give you sufficient data so that you can predict a point, and then from there you are able to get the equation. Then they ask you a subpart that, come on now, for this where do you find, and things like that. So that's what, it's totally keeping up with the trend. So we know the equation, but we have to introduce it. So let's introduce. Let the arch be as shown in the figure. What else? Then we need these vertices. You cannot work without vertices. A can be here, B can be here, this could be C, then this is what we require, D and E, right? So all this we'll introduce. Let AB, they call it something, width or something. Let AB be the width of the, be its width, right? Then OC be its height. That's what they have told us. Then BD be the point, or D be the point at which its height has to be found. Its height has to be found. Just to introduce the problem. So many things. Okay, so see, this is just the introduction, and you have to give the parameters actually, I mean the values, and not and, here AB is 8, so that makes AO and OB, which is symmetric always, a half of AB, which is 4. So that way we get this much part as 4 and this much part as 4. So this much part basically will be 4. Right, then we have OC, and OC is given to us as 2 meters. Right, but they say that BD is 1.5 meters. So and OB is 4 meters. So like that, OB, which is made up of BD plus OD, is 4 equal to 1.5 plus OD. So like that you can get OD when you can have this going there. 4 minus 1.5. What will be that 4 minus 1.5? It will be 2.5. So that is 2.5 meters. So we have almost everything ready with us. This much distance is 2.5 meters. So we are interested, always distance is from the origin that we are interested. From the end we are not interested, okay, because that can only give you parameters. So that is why we are interested in that value. Okay, so if we are planning to take up, then we can tell about the equation. Let the equation of this ellipse be, x squared by a squared plus y squared by b squared equal to 1. Now this we have to search and find out each of these. What is a and what is b and all that. With the data that is given to us, we are able to predict what is a and b. From given, what is a? A is actually like how we have the total length of the major axis, yeah, so it's like 2a. From given, 2a is 8, so a is 4. So a is done, and b is a total distance to b is a total distance to a minor axis. So b directly it's given to us. Also b is 2, that is directly given to us, 2 meters. So therefore the equation is x squared by 16, 4 squared, y squared by 2 squared. If you want 4 squared, 2 squared equal to 1, which is x squared by 16 plus y squared by 4 equal to 1. That is the equation that you're getting over here. Then they ask us to find out this height. If you have to get this height, then you can look at this point, 2.5 comma k, if at all it is. If you are able to have that k, then you will get the height. So to find ED, let ED be equal to k. Therefore coordinate of E will be x distance 2.5, y distance k, and E belongs to the ellipse, semi-ellipse but ellipse. So therefore it satisfies, right? Satisfies means x and y. So x squared by 16 plus y squared by 4 equal to 1. How do we go across it? It is 2.5 the whole squared by 16 plus k squared by 4 equal to 1. You can have this equalized into 4 into 4. So what will come? 2.5 the whole squared by 16. Oh, we have it whole 16 plus 4k squared because we're planning to equalize it. 1. Let the 16 go there. 4k squared plus 2.5 the whole squared equal to 16. 4k squared equal to 16 minus 2.5 the whole squared, we all know is 6.25 because 25 squared is 625, 6.25. How much will this come to? 16.00 minus 6.25. Let's have it 5, 10, 9, 10, 5, 7, 9. So 4k squared is 9.75. So k squared is 9.75 by 4. How much is that? 4 2s are 8, 1 remaining. 4 4s are 16. 4 3s are 12. And 3. So that's 7. 28. 2. Broadly k squared is this. And if you want to find the k value means you have to take the root of it. So let's take the root of it. 4 3 7 5. 1 1s are 1. Then 1 remaining. Before we take the decimal, we put it in the quotient and take the 43 down. 2 how many times? Can we have 25 5s are 125? What about 26? 6 are 6 6 are 36, 6 2s are 12, 150. No. So 5s are 125. We have attached 5. So it is 30. Remainder here is 13 and 5, that's 8. And 1. And then you can have the remaining lot, 7 5 coming down. And you can see what you can attach. 305 or 306. 5 5s are 25, 15, or it can be 6. 6 6 are 36, 18. Yeah, you can attach a 6. So it will be, yeah, we are not bothered of going still in front. So k becomes now how much? 1.56. So if k is 1.56, that is indirectly the required height also. So what happens is, therefore ED becomes 1.56 meters. And then we have to conclude it the way they have asked us. What is that? Height of the eye, the required height. Therefore, required height is 1.56 meters. That's about this. I think that was also a huge video. We can take up for the next video. Thank you. So that's about this problem.